Right here, welcome to the topic that handles our daily applications, thermal energy. In whatever we do every day, call it cooking, we need this. And many people had misunderstanding about this. When you ask people to define heat, they end up defining temperature. But today we will know more what thermal energy is all about. Talking about thermal energy is an internal energy. It comes from within. It's an internal energy that results from collision of particles and is transferable from a hotter body to a cold body, and also changes variation in temperature. So in definition, we'll say that thermal energy or heat, another name for thermal energy is heat. That is an internal energy that is transferable from where we'll have high concentration of temperature to a place we'll have low concentration of temperature, and it causes change in temperature. From there we can bring effects of heat on matter or body. First, heat causes change in temperature. That one is included in the definition, and that's the basic thing. It causes change in temperature. Secondly, it causes expansion. Third, it can cause physical change or changes in physical properties. It can also cause changes in chemical properties. It can also even cause change in color and some other things. Now we look into parameters which heat depends on. Many times we talk about heat. But there are things that which heat depends on. First is nature of the material. Nature of the material. If I have a metal and I have a wood of the same size and I place both of them on a stove or a gas cooker, you don't need a prophet to tell you the one that will get hot first. The metal will be hot gone while the wood is still acquiring little heat. So we'll say that heat depends on the nature of the material. Why is the metal hot and the wood is not hot even though they are of the same size? Because of what? The nature. Secondly, heat depends on mass. Mass of the material. People may not know, but it's true. Heat depends on mass of the material. If I have something that is as big as this, and I have another one that is as small as this, and I place the same two of them on the same fire, you notice that this one will be hot and turn red, while this one is still acquiring heat. And after 3 hours, bringing them out and dropping them on the floor, you will notice that this one will get cold after 1 hour, while this one is still very hot. Why? Because heat absorption is equivalent to the mass of that. So we said mathematically that heat is directly proportional to mass. This we cannot say on nature, because scientifically nature cannot be predicted. For example, if I saw you take the test or experiment on the hair of Sayudi, you can come in now and say, the hair is wet. In the next 2 minutes, something may happen and the hair will be dry. And that means in nature there is constant variation. So we cannot take care of that. So what do? We place a constant that will take care of that particular thing that man cannot do on the study of nature. But now on mass is directly proportional. Now thirdly, we'll say that heat is directly proportional to change in temperature. That means heat depends on change in temperature. Change in temperature. Now, the more you have maybe increase in temperature, we'll say that heat or more absorption of heat, temperature will be increased. And more a body liberates heat or emits heat, temperature reduces. So we'll say that heat is also directly proportional to change in temperature. Looking at these three things now, many a times in examination you will see something like this. Write out 3 things which heat depends on, or write out 3 parameters, or states the parameters which heat depends on. my dearest? First is nature of the material. Secondly, mass of the material. And the third one is change in temperature. But bear it in mind that nature of the material in physics is considered amathematical, while mass of the material and change in temperature in physics is mathematical. And since they are mathematical, that is why we have mathematical equivalent representing them. So bringing it down, we can say that heat is directly proportional to mass and directly proportional to change in temperature. Bringing it into a single variation, that means that heat is directly proportional to mass and change in temperature. And as I told you before, that proportionality sign is a dummy sign. And you can't use this to get an actual answer. It's just like proportionality simply means it looks like something that is like. But if we want to have an equivalent or equal, we now put up a constant. And that constant, we say that H is equal to mc delta theta, where this C here is the constant of proportionality known as specific heat capacity. I called it specific heat capacity. That is the constant of proportionality. While this is the heat absorbed or quantity of heat, while this is the mass and this is change in temperature. This here, they are proportional, but this place now, it is equality and no longer proportional. And this is the equation of quantity of heat. Considering this equation, which I told you that the equation is the equation of quantity of heat, looking at here, we see the constant of proportionality C, which is the specific heat capacity. I know you may be asking, what is specific heat capacity? Now we introduce that and define it. Whenever you hear the word specific heat capacity, even if that is seems from the name specific, it means that it's doing a particular job. When you hear specific heat capacity, it simply means the quantity of heat required to raise the temperature of a unit mass of a body through 1 degree rise in temperature. Now, from this equation of quantity of heat, if I'm making it the subject of the formula, we have C equal to H all over m delta theta. In physics also, we have heat capacity or thermal capacity, which is not specific. The specific here simply means that this is working on a unit mass, maybe 1 kilogram. But we have heat capacity, which is the quantity of heat required to raise the entire mass or the whole mass, to raise the temperature of the whole mass of a body through 1 degree rise in temperature. Don't get confused about two of them. This is heat capacity and this is specific heat capacity. This one works on the entire mass or whole mass, while this one works only on what? Unit mass. Both are doing the same thing. And what is their work? Raising the temperature through 1 degree rise in temperature. But this one is interested in only raising the temperature of a unit mass, while heat capacity is interested in raising the temperature of the whole mass. So, bringing heat capacity or using the method I always use to explain that. I said that here is C, 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 and C. That is heat capacity in all. That is CP. Each one here is 1 unit. So specific capacity is interested in that. But the whole body is CP. That means heat capacity is interested in that. So if I check this now, 1, 2, 3, 4, 5, 6, 7, 8, we'll say that 8 C's is equal to CP. You ask yourself, what is that 8? 8 there simply means the mass of that body. Because if you look at it, this is C, a unit mass. This is another C, a unit mass. That means this is 1 kg, 2 kg, 3 kg, 4 kg. That is 8 kg. And we said 8C now. If I count this, it's 8 in number. 8 C's is equal to 1 CP. That means that CP equal to 8 C's. And that 8 is mass. So I have the right to say that CP, which is heat capacity, is equal to the total mass of the body given times the C, which is the specific heat capacity. And Introducing this formula or relating it to this one, we'll say that Cp is equal to m dot, my C, remember, is the whole of this. I can bring it down and say h all over m delta theta. M will go with m and they will travel to honeymoon. That means that Cp is equal to h all over delta theta. And this is the final answer for Cp. Why this is the final answer for C? Please don't get confused about it. C is specific heat capacity interested only in a unit mass, while Cp is heat capacity interested on what? The whole mass. And taking thermal energy from the point of definition down to the parameters which it depends on, and driving us through the calculations down to this point, I think these are the basic things you need to know for any examination.